Concrete is literally the most used man-made material on Earth. It's everywhere. Our homes, our bridges, you name it. But here's the thing a lot of people don't get. Its incredible strength isn't guaranteed. It all comes down to one single moment, the pour. And if you mess that up, the entire building could be at risk. Okay, so here's our game plan for today. First, we'll look at the hidden dangers in a bad pour. Then we're going to do a little autopsy on what a failed pour actually looks like scientifically. We'll put the right and wrong ways side by side, show you how the pros fix mistakes, and then wrap it all up with the golden rules you need to know. Right, first things first. Let's talk about the stakes here. What really happens when a concrete pour goes wrong? Think of it like this. You see a rough, ugly patch on a concrete wall and think, it's just cosmetic. But that couldn't be more wrong. That visible flaw is just the tip of the iceberg. The real problem, the serious structural weakness, is hiding just beneath the surface, and it can threaten the safety of the whole building. To really get this, there are two terms you absolutely have to know: segregation and honeycombing. They're kind of the twin villains of bad concrete. And believe me, they are directly connected. Let's break them down. Okay, imagine you're making the perfect cake batter. Everything is mixed beautifully. Well, segregation is what happens when all the heavy chocolate chips sink to the bottom. In concrete, it's the heavy stones and gravel separating from the cement paste. And when that happens, you don't really have concrete anymore. You just have weak pockets of gravel and globs of cement, and neither one is strong on its own. And honeycombing, well, that's the ugly evidence that segregation happened. It's that rocky, porous surface that looks, well, just like a honeycomb. It means the cement paste, the glue holding it all together, never made it to those spots. It's not just a surface flaw, it's like a gaping wound in the structure's skin. So, if those are the problems, how on earth do we prevent them? It all, and I mean all, comes down to technique. Let's look at some real-world comparisons of doing it right versus, well, doing it very wrong. Just look at this. On the left, that's the classic mistake, pouring at an angle. The concrete slams against the rebar and the form, and the heavy aggregates literally bounce away from the paste. But look at the right. That's how it's done. A clean, vertical drop. The mix stays together, flowing down and filling every single nook and cranny perfectly. Now, this is a pretty cool technique, especially for deep things like walls. The wrong way, on the left, is just dropping the concrete from way up high. That's a guaranteed recipe for segregation. But the pro move on the right, it's genius. You pour into this external pocket, and it lets the concrete flow gently into the form from the side. The mix stays perfectly intact. And this shows a super simple but critical rule for big flat surfaces like a floor slab. On the left, they're dumping new concrete far away from the last batch. That means you have to drag it over, and that friction causes, you guessed it, segregation. The right way is so simple. Always pour the fresh stuff right next to the existing wet edge. Let them merge together naturally. It's that easy. All right, if you take away only one number from this whole explainer, make it this one, 1 meter. That's about 3 feet. It is the absolute non-negotiable maximum height you should ever let concrete free fall. You go any higher and the force of the impact will literally rip the mix apart. It's the simplest rule, but it prevents a ton of problems. Okay, but what if the damage is already done? What if you're staring at an ugly patch of honeycombing on a project? Well, don't panic. Structural engineering has a very precise, step-by-step way to fix it. And it's not just about slapping some putty on it. It's about restoring the strength. So this is basically surgery for concrete. First, you have to get aggressive and chisel out every single bit of weak, crumbly stuff. If you hit steel rebar, you have to clean it and coat it with a protective epoxy to stop it from rusting down the road. Then, you apply a special bonding agent. Think of it like a primer, so the new patch will actually stick. Finally, you use a special non-shrink mortar mixed with very little water to make it super dense and build the surface back up. Every single step is critical to get the strength back. So, we've seen the problems, we've seen the techniques, we've even seen the repairs. Let's boil this all down into a clear, simple playbook for the perfect pour. All right, let's bring it all home. These are the golden rules. To stop segregation, you pour vertically and keep the drop under 1 meter, period. To make sure it's solid, you use a mechanical vibrator to get all the air bubbles out, and you work in nice, even layers. And for a perfect job, make sure your forms are clean and sturdy, and always, always pour new concrete right up against that wet edge. Following these rules, it's the difference between something that lasts a few years and something that stands for generations. So from now on, when you walk past a construction site, you're not just going to see a building going up. You're going to see science in action. You'll understand the invisible forces at work, and you'll actually be able to spot the difference between a job done right and a disaster waiting to happen. The world is literally built on this stuff, and now you're in on the secret.